Last section that's on the test, math models. So how do we express the distance? Do you guys remember the distance formula? Yeah. From your algebra days? The distance between 2 points, I mean? Distance, yeah, it's got a big square root in it. Distance between 2 points. Square root of x1 minus x2 squared plus y1 minus y2 squared. Remember that thing? Yeah. All right, that's what we got to use. We want to go the distance between what 2 points? Well, it says from P to the origin. What's the origin? 0, 0. 0, 0. And what's P? It says right here, xy. So we're going from xy to 0, 0. So those are the two. So we want a distance formula. It's saying from P, which it called xy, it's just any old point P, call it xy, to the origin, 0, 0. So what's that going to be then? So x1 minus x2, so that's x minus 0 squared, plus y1 minus y2, y minus 0 squared, all in a big square root. Good so far? And then x minus 0 is just x squared, y minus 0 is just y squared. Just cleaning that up, right? X take away nothing is just x, and y take away nothing is just y. So there's the distance formula. Good so far? But one more thing, they want us to get that distance formula in terms of only one letter. They don't like the fact that we have x and y. We don't like it either. Can't put it in our graphing calculator that way. So what can we do? We can come back up here and take this and plug that in for y. See what we're going to do? Because we're on the graph, we're going to be, on the graph, y equals x squared minus 7. So we can plug that in for y. Right there. So we'll get distance equals the square root of x squared plus y. And what is y? X squared minus 7 quantity squared. Everybody see that? See what happened there? It's just in the way. Everybody see what happened? So I just plugged in for y right there, what y equals. So what we're saying, let me set this problem into like reality for you. What are we even talking about? You guys know, huh? What is this graph? What is the graph y equals x squared minus 7? What does it look like? What's the general look of x squared minus 7? It's a U shape. And where is it? What's the minus 7 do? Down. It's a y effector, right? Because it's not like this. It's not x minus 7 like that'd be an x. That'd be a right left kind of 7, wouldn't it? But it's not that way. It's outside of the x, so it's a y effector. So it's down 7. So it's basically down here at 7 and kind of goes up from there, huh? So that's the graph y equals x squared minus 7 in general. You know that. Okay, so what are we even talking about here? Well, they're saying, where's the origin? Well, you know the origin's right there. There's 0, 0, the origin. And they're saying, hey, of all the millions of little points that are on the graph y equals x squared minus 7, which point is closest to the origin? If you're a little person, for example, walking around on the graph y equals, walking back and forth on the graph y equals x squared minus 7, at what point are you closest to the origin? That's the question we're going to eventually answer. So which point? Where do you think, if you just had to guess, generally, where do you think it is? Well, my picture's not very good. There's no point in it. Basically, it's going to be somewhere around over there. There's basically going to be a point over around here, so somewhere around in here, that's going to be the closest point to the origin. And the same exact point is going to exist over here. They're going to be symmetric, right? So it's going to be, those 2 points are going to be equally distant. I don't know exactly where it is right now. I'm not saying it's exactly in the middle. It's not exactly in the middle. It's just somewhere in each of these sections there is a closest point. That's our goal in this problem, is to find the closest points to the origin among all the points that are on that U-shaped graph. So to do that, first thing we have to do is we got to set up a formula for what the distance is. What the distance is right here between it says D, the distance between the origin and any point on the U shape. What is the distance between them? Well, it's the distance formula between any 2 points. Difference of x squared plus difference of y squared, square root over it. That comes from the Pythagorean theorem. I don't know if you remember the distance formula comes from the Pythagorean theorem. Anyway, whatever. We don't have time for that. But so the 2 points are x, y, and 0, 0. So I just plug them in. Plug in x minus 0 and y minus 0 squared. Get this. And now what do you do right here? Well, any point on this graph, the y value equals the x value squared minus 1. So I plugged in for y, x squared minus 7, because y is x squared minus 7. So y squared is x squared minus 7 squared. Good so far? So I've got a distance formula now only in terms of x. Let me go to fresh screen. Got a little more work to do on this one. So again, where are we at right now? We got the distance formula, which started off as x minus 0 squared plus y minus 0 squared, which is x squared plus y squared, right? Because it's the distance from 0, 0 to xy. Right? That's what we're talking about. Distance from the origin to any point xy on this graph. But since that point xy is on this graph, I'm allowed to plug in for y right there and get x squared plus, and then what becomes of that y? X squared minus 7 squared. We good to there? So now let's work that out. Let's clean that up. So ready? So x squared plus, and this is going to be x squared minus 7. In fact, let me just change the color, make it easier to see. So x squared minus 7 times x squared minus 7. Okay, distribute. X to the 4th minus 7x squared minus 7x squared plus 49. Good so far. I just foiled that whole thing out there. Let me make this first one the same as it was. Everybody seeing that? And so now clean that up. Gather like terms. I'll do highest power first. X to the 4th. X squared minus 7 minus 4 is minus 13. X squared plus 49. Good to there? So far so good? So I just foiled out the x squared minus 7, gathered like terms. So that's, what is that? That's the distance. That formula represents the distance from any point on the graph, y equals x squared minus 7 to the origin. Pick any point you want, give me the x value, and we'll do it. So now look what it says in part B. What is D if x equals 0? What are they talking about? Let me ask you this. What if I said, hey, I'm somewhere on this U shape. Forget about the origin for a minute. I'm somewhere, I'm walking around. I'm a little person walking around on the graph, and my x value is 0. Where am I? This is like, where's Waldo? So, right, I'm walking around on the U shape. I'm a little person walking around on that U shape, and my x value is 0. Where am I? Which point on this U shape has an x value of 0? Straight down, right here. Isn't this over 0? I don't know what the y is there. But isn't that the x value of 0? Isn't that the only point on the U shape with an x value 0? That's where I must be, huh? You with me? Oh, and how far down is that? It must be 7 because it's minus 7, huh? So that actually must be over 0 down 7. Right? Because this graph is, x squared minus 7. So when x is 0, y is down at 7. Yeah. So that's the point I must be at, huh? When x is 0. And that's what they're saying. When x is 0. Now you tell me, guys, if you're right here straight down, how far are you from the origin? Well, 7, huh? Because this is 7 away. So what that means is if I put 0 into this distance formula for x, if I plug in 0 here and here, what am I going to get? square root of 49, which indeed is 7. I'm just showing the distance formula is telling us the truth. It's not lying to us. It's telling us the truth, isn't it? It's saying when x is 0, the distance will equal square root of 49, 7, which is true. When x is 0, your distance from the origin is 7. We're just kind of, in part B, they're just wanting you to see, the thing's working. It really is giving you you give it an x value, it'll tell you how far you are from the origin when you're at that x value on the U-shape. Is that making sense? Everybody seeing what's happening mechanically? I can pick any x value I want, plug it into this distance formula, and it'll tell me when you're at that x value, how far you are from the origin. Make sense? So, what it says, part C, what if x is 1? So you can just plug in 1 and you get some crazy number. So I can just do that on the next part. I'm going to go to a fresh screen if that's okay. This is like a multi-screen problem here. So we were at d equals the square root of x to the 4th minus 13x squared plus 49 minus 13x squared plus 49. So then in part C, they're saying let x equals 1. So that's just use your calculator, plug in x is 1. And hit the old buttons on the calculator. And you get something, I guess you get round to two places, 6.08. I'm just looking at the answer here. So is that okay? Just use your calculator there. So they're just having you plug in a couple x values and find some distances, nothing amazing there. And then on part D it says, use your graphing utility to answer the following question. For what positive value of x is d smallest? So in other words, what we want to do is we want to say, okay, I understand that, we got this U shape and we got the origin, and this, what is this formula good for? You give it the x value, it tells you the distance from the origin, right? When you're on the U shape, though. It all came from the U shape. Remember, we plugged the U shape, remember back here, how we even got this thing? Right here, I plugged the U shape formula in for y, for somewhere here. Plugged it in for y, and we worked it all out, huh? So this is only for when you're on the U-shape, because we plugged the U-shape into that distance formula, didn't we? Right? So what that means is, you give it an x value, it'll tell you the distance at that x value from the origin. Everybody getting that idea? So you give it an x, it tells you the distance you are from the origin. So what do we want to do? We want to find the point that is closest. We want to find what x value on the U-shape is closest. Or in other words, distance is smallest. That's what closest means. Smallest distance, right? Of course. So how do you do that? Do you realize that's not something we've done before? Probably not. That's probably something you've never done before in all of algebra. This is new. This is beginning of calculus is what this really is. Smallest, closest, and in a little bit we'll do furthest, biggest, tiniest, largest, highest value, all the EST words called superlatives in the English language, right? They have big, bigger, biggest, right? That's the ist case is called the superlative. It's the most, right? So whenever you want to answer the most case in math, that's a maximum minimum function is what that is. To find smallest distance is to find the minimum distance, isn't it? We want to minimize distance. You realize that's what they're actually asking? So I'm trying to help you know, because you know it's hard on a math test, right? You're going to get tomorrow, the practice, you'll see what I mean. You'll look at that thing, I'm sure you'll have to some degree a little bit of a, wow, some of them look alike, how do I know which one's which one? So let me help you with that. When you see this EST word, smallest, largest, biggest, closest, you think, oh, that's that calculator maximum minimum, for sure. That's what that is. So when you see the EST, the superlative case, that's use your graphing calculator and do the maximum. So smallest is minimum, isn't it? It's minimum distance. So what that means is I've got to take this thing on my graphing calculator. You guys have a calculator? Put this in for y1 now and graph it and find the minimum. That'll be the minimum distance. That'll be the closest point. Does that make sense? So that's where we're going now. I just sent you an email last night, right? I'm always emailing you. right, to all your whatever email you put in Math Excel with a minimum maximum distance YouTube thing, in case you have any trouble with that. So yeah, so let's do that. So I'm going to go to the graphing calculator. I'm going to put that function in. Let's do that. And so go to y1. Oh, I got the wrong function in there. All right, so we got a square root of. So you got to do the square root button, square root of, and then the parentheses, and so it does it automatically. And then x to the fourth minus 13x squared plus 49. X to the fourth minus 13x squared plus 49. That good? Put that in y1. You good? Put that in there. And where should your window be? I have no idea. That's part of the problem. So let's just, I think it's just, I just have the standard window right now, negative 10 to positive 10, negative 10 to positive. It probably won't work at all. Let's just hit the graph button and see what happens. Hey, we got something. Hey, actually, that's fabulous. Normally these don't work at all at first. That's great. That worked perfect. What am I trying to even find?
You're looking for the positive x.
Either one. I want the minimum. So I want those two valleys, right? Right here and right here. There's a positive and a negative. Remember we said there'd be one on each side? Sure enough. So I want to find either one of those minimums. You with me? So you know how to do that, right? Hit second calc. Where it is? Second calc. Go down to minimum. It's even easier on the Casio. Go over. So I'm going to find this one over here. You can find either. They're going to be the same number, one positive, one negative. It doesn't matter. Just find one of them. Go over here, and just remember it says go left of it, right of it, on it. Right? So I'll go, okay, there I am, left of it, enter. Okay, go right of it now. Okay, I'll go right of it, enter. And now go right on it, best you can. Boom, there we go. And there I go, 2 point, make that even a little bigger there. 2.549. I don't know how many places they want. Round to 2 decimal places, yeah. So 2.55, I guess, yeah. So x equals 2.55. And y is something else, but whatever. Y, I'll write down y just in case they want it later. 2. It would round to what? 2.60? Y would round to 2.60. Is that okay? Is that too quick? See what I did there? So I just typed that distance function into y1 and graphed it. My window was, in case you missed the window, my window was just negative 10 to positive 10, negative 10 to positive 10. And it was good. Normally, in a minute, we'll have to adjust our window a lot. But that one worked out naturally good. Is that good? To there? Is that okay? Come back to the screen. So, and that's all part of. So yeah, all they want is that x value. So there we go. We found, and where is that? Well, I don't know. It's somewhere over here. Somewhere over here. We found the x value of the point that's closest to the origin. The x value is at 2.55. It's also a negative one over here. And they did say positive, didn't they? So they only want I didn't notice they only want the positive one. So they don't want the negative. Good there? That's question number 1. All right, so I'll give you a minute. Try that one. So same kind of thing. Write the distance formula. Do all the same stuff we just did. This time, instead of the only difference on this one, guys, is instead of the origin, it's the point 10. So you're not going to use, so you're going to use 10 and xy. We always use something and xy when we do it. So do your distance formula now for 10 and xy instead of 0, because last time they said the origin. This time they're saying 10 and xy. So set up the distance formula, put it into y1 in your calculator, graph it, find the minimum. Same kind of stuff. So point out Roberto, there's our tutor Roberto, he's got to run, he was checking in with us, he's got to run, so he's there to help you. His arrows are in the back. See Roberto, they're all back there in the back, check, get the help you need. Our exam's next week. All right, so it's the square root of the difference of x's plus the difference of y's. like that. Isn't that good? Good so far? Doesn't matter what order you do it in. Because it's squared. So the order of subtraction will just change the sign and squared won't matter. So the order doesn't matter on this. So if you have x minus 1 squared, that's fine too. That's the same thing. Do you realize that? Because if you subtract two things, like 7 minus 2 or 2 minus 7, the only difference is the sign of the answer. And if you're squaring it, that therefore doesn't matter, does it? All right, so we good so far? So then work that out. Just, distribute it with your calculator. Or not your calculator, by hand. This is going to become y squared, isn't it? Because negative y squared is just y squared. The negative vanishes. We good there? And then what do you plug in for this y here? Because you got to get it to be all x in the end, huh? Yeah, this one's going to come out a little bit nicer, isn't it? Y is the root of x, so plug right in there, root of x, and we get root of x squared. And what's root of x squared? That's just x, huh? That's nice. So we go, it's 1 minus x plus plain x, isn't it? Root of x squared is just plain x. We still got to FOIL this all out. But is that good so far? Not making sense there? So we write the distance formula on it. Yeah.
Does it matter the order, like which one's x1 and y1?
Yeah, no, it doesn't matter because when you subtract two things and you square them, just think about it's a good question, and the best way is always to test. Just think. So if I'm middle of a test and I was wondering, I would say, let me think about numbers. Is 7 minus 2 any different than 2 minus 7? And remember, they're squared, right? So is that going to actually matter? Well, this would be 5 squared, and this would be negative 5 squared. Oh, so in the end, they're both going to be 25, huh? Yeah, so good question. The answer is, therefore, it doesn't matter. The order of subtraction, when something's squared, doesn't matter. So that's why it makes no difference. We good so far? So now we just got to FOIL that all out. Let me go to a fresh screen if that's okay. So we have distance equal the square root of, did I write 1 minus? Yeah, 1 minus x. You can write x minus 1 or 1 minus x, doesn't matter. Plus x, and so boop, bada boop, boop, bada boop. So 1 minus x plus x squared plus x equals the square root of x squared. These guys cancel. And it's minus x plus 1. Did y'all get that? Okay, to there. So then put that into y1 in your calculator and graph it. And if you don't see a good graph, you're going to have to adjust the window. That's really an important skill to get comfortable with. So give that a try. Put it into y1. I'll do it too. I don't remember what happens. Square root.
It's a nice
We got that? You guys putting that into your graphing calculator now? I just put it in to my little screen, and I got a pretty good graph. Actually, I didn't have to mess with it. I'm still just set up on negative 10 to positive 10, negative 10 to positive 10, and I got something that kind of goes like this. Well, anyway, I think the minimum is right around there, looks like, on my screen. So I'm going to find that minimum. There's what came out on my screen. Looks like the minimum is just a little bit right of 0 to me. So I'm going to go second calc, go down to minimum, and go left of that spot, right of that, left enter, right enter, on it, enter. Boom, left enter, right enter. 0.4, no, that looks like 0.50. Huh. X is 0.50. So X is 0.50 on that one. We good with that? Found that? Yeah.
Was that the answer right there? Were the equals for the x squared minus x minus
They want several things. Let's go back and see. Okay, so right triangle, blah, 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 blah. Express the area. Okay, so what's the area of a triangle formula in general? Half base times height, right? Remember that one? Half base times height. Now, when we say base and height, what if I said, hey guys, I'm going to measure my height. You ready? I'm going to take a tape measure, and I'm going to go diagonally down to the ground. I'd be ready for the NBA, huh? Right? I'd come out like 8 feet tall. Right? That's not height, is it? So I just want to key real clear in your mind. Height means straight down to the ground. That's what it means. So when we say base and height in any kind of formula, they have to be perpendicular to each other, don't they? Because that's what we all know we mean when we say height, straight to the base, straight to the ground, huh? So therefore, these two are base and height. Or vice, it doesn't matter, you can call this one base and this one height, or vice versa, but it's not the diagonal one, huh? Because height is straight to base, isn't it? It's straight to the ground. So those two are your base and your height, or vice versa, it doesn't matter which is which, but it's not the other side, right? So, okay, so well, how long are those? How long is it from there to there? Y. That's what this over 0 up y means, huh? This is a height of y, right? Does that make sense? Because this is the point right here, over 0 up y. So from there to there is y. How far is it from here to here? This is over x. So it must be over x, right? Everybody with me on this? Because this point, how do you get to this point? You go over x, up y. So how far over do you go? X. How do you get to this point? You go up y. So this is over x, this is up y, so the height is y, and the base is x, so it's a half xy, right? The base is x, and the height is y. Good so far? And there's our formula, except we don't want two letters. You know, it's always what they're going to say. You don't want two letters, so what do? Just grab right here, y equals x to the 6th, plug that in for y. A half x to the 6th. So that's a half x to the 7th. We're done. That's all they want on that one. So we just found a formula for basically any x value what the area of that triangle would be. As you go out that parabola, it makes a bigger and bigger triangle. Does that make sense? As you go along here, anytime you stop, you're making a triangle with area. And depending on your x value, that'll be the area of the triangle. That's what we just found. All right, I better keep moving. Okay, so basically they want me to find the area of this little rectangular box here. What's the area of any rectangle? Yeah, length times width, base times height, whatever you want to call the two sides. Right? No half, because a triangle is half of a rectangle, isn't it? Well, turns out a right triangle is half a rectangle. Technically, a triangle in general is half a parallelogram. But anyway, good enough. That's where the half idea comes from. So sometimes I say things that aren't true to make them seem simpler. But anyway, so yeah, so that's where the half comes from in the triangle formula. For the rectangle, we just have one side times the other, length times width, base times height, whatever you want to call them. One side times the other. So, okay, but I need like x and y and stuff. Here's the width, here's the length, or you vice versa, it doesn't matter. So how far is it from, how far is that width? Well, use the xy. Here's the point xy. So isn't that width over x? And isn't that length up y? Yeah, it's just x and y again. The length is just y, the width is just x, or vice versa. It doesn't matter what order you put them in. It's just x and y again, right? Isn't this point over x up y? That's what it means to be a point on a graph, huh? Over x, up y. So width is x, length is y. And so now, and you know the deal. Just take this, plug it in for y. So 36 minus x squared times x. And then we can distribute, boom, boom, like that. And we'll get 36x minus x cubed. There's the area formula. Is that okay? So what did I do? I just said they want the area of this rectangle. That's what they're asking for. It says it over here. They want area. Area of a rectangle is just one side times the other. So I just said, well, this is over x, up y, so it's just x times y. Plug in for y. Now, there's some other parts, though. Look, it's 36x minus x. Okay. Okay. So we got this thing. We're gonna make a box that has no top out of that piece of cardboard there. That's the question. Is basically take that piece of cardboard and make a box. This is a kind of question that is super valuable because it's basically, in the end, we're going to say, how should you do that to make the box that'll hold the most, biggest volume? Same piece of cardboard, depending on how you cut the corners out, you can make more volume or less volume, same amount of cardboard. If you just cut out a little bit from the corners and you fold, and then you fold this out and fold these guys out and make your box, you know, if you just cut out a little bit, then the box won't be very high, right? It'll be a pretty short box, but it'll be wide and short. If you cut a lot out of the corners, cut way in, then you get a box that's tall, but the base is tiny. So you're constantly playing back and forth with how big the base is and how tall the thing is. Taller box, thinner base. Wider box, but shorter, right? Which one's going to hold the most volume? Well, who cares about this? Well, UPS, FedEx, big dollars to them. They take cardboard and make boxes out of them all the time. What's the cheapest way to do that with this? You know, what's the way to take the box and make the most volume? They pay math people, science people to come in and calculate these things for them because that's, you know, in one box they might save, you know, I don't know, 10 cents or 20 cents because they make it hold a little more, but they ship so many millions of boxes every day. That adds up to a lot of dollars if they can make every box a little more efficient. So how do we do that? Very practical question here. How do we do that kind of thing? Well, first off, we got to get a volume statement for the box. How do we do that? What's the volume going to be? Can you picture the box here? Over here on the side. How tall is this box going to be? It's going to be X. Everybody see that? Because this little X piece, these little X distances are going to fold up and become height, aren't they? Can you picture that? That's going to become the height when we fold up the little X flaps here over here too. We're going to cut out those corners and then fold up. So this distance is X from here to here and from here to here, and we're going to fold it up. So the height is X. What's the inside dimensions of the box? Like the width and the length. Well, if you look at this picture here, it's 18 is all the way, like it says in the diagram there. And I want to know just from there to there, don't I? Because that's going to become, in fact, let me just move it right here. You can see it better right here. From there to there is going to be the width, isn't it? Because the two sides are going to fold up, and that's going to be the new width. Well, what is that? Well, it's 18 all the way, take away X, take away X. It's 18 minus 2x, isn't it? Does everybody see that? 18 outer edge to outer edge, take away the two x's, and you have inner edge to inner edge. Everybody see that? So the inner width, inner edge to inner edge, this width right here, is going to be 18 minus 2x. And then what about this dimension, the length, which is right here? Same thing, huh? Because it's 18 all the way again. Minus x, so it's also 18 minus 2x, isn't it? Because again, 18 is outer edge to outer edge, inner edge to inner edge is 18 minus 2x. So there it's the same. So in the end then, the volume of a box is length times width times height. Just multiply the three dimensions. So the volume of the box will be 18 minus 2x, 18 minus 2x, and x. So the height is x. This out of the way. Everybody good with that? So there's the volume statement. That's how much volume would be in that box. 18 minus 2x times 18 minus 2x times x. Okay, so then we got to FOIL all that thing out. So let's FOIL these guys first off. So 18 times, is that 364? 324, thank you. 324 minus 36x, I'm just foiling right now, minus 36x plus 4x squared, and that x just waits out front. And so that is 324 minus 72x plus 4x squared x, like that. And then distribute that x all the way through. Boom, and a boom, and a boom. Volume is 324x minus 72x squared plus 4x cubed. There's our volume statement. So now you could put that into your calculator as y1 and hit the graph button, and you could find the x value. See if we have time for that real quick. So put that into your calculator as y1. So 324x minus 72x squared plus 4x cubed. I don't know what the window should be. Let me help you with the window. The window x, what's the biggest x could be? X is some little amount, right? The biggest x could be is 9. If you did 9 from each side, that's the whole 18. X can't be any bigger than 9, because x is how much you're cutting out from each corner. If you cut out 9 and 9, you've got the whole 18 cut out. So it's not going to be any bigger than 9. So let x go from 0 to 9. And y starts at 0 and, I don't know, what, 100 or 1,000 or something. So probably you can just use the screen we just had. Oh, mine's going too big. So I just graphed. Let me just show you this real quick. I just graphed with the screen I just had, like 0 to 9 to 100, and it just went flying off the top like that. So what should I do whenever I see that? Go to table. Yeah, hope that's making sense for you. I really want to. I learned that last semester, and I never realized how helpful that is. Hit second, and whenever it's like flying off screen, hit second table, and it'll show you where the y's are. Go, oh, look, the y's at 392. You can go down. Just go down, see where it's going. 4, 5. Oh, so 500. If I go up to 430, 500. 500 should cover it, right? Looks like the biggest y values I need are 432. So 500 should cover it. See how I'm figuring that out? Go back to window and go, okay, I'm going to go 0 to 9 on the x and 0 to 500 on the y. So 0 to 9, 0 to 500. Graph. And there it is. There I get. So you can find that x value. That'll be the best box. The best way to cut it, make the box that'll hold the most volume, whatever that x value is. These are valuable, guys. Make sure you spend time. And no secrets with me. There's 2 of these on the actual exam. There's one of the distance ones, and there's one of these box kind of ones on the exam you'll take next week. So practice these. Tomorrow's the practice exam. Come with your Scantron, and we'll spend our time that way. I'll see you tomorrow. Hang on to your questions. 2.6 is due tomorrow. Yeah, bring both if you can. Yeah.
After we take the practice exam, will it be online?
I'm going to go over it on Tuesday when we come back. So I'll run it through. What I'll do is when you finish, I'll run it through Scantron and give it back to you all the answers. But as far as going through the steps, that'll be when we come back on Tuesday.
But it won't be online anytime between 2 p.m. There's only one night, right?
Yes, it'll just be on that day. Let me see if maybe the other class. When do I do theirs?
The next day.
Yeah, no, I do theirs Tuesday also. Yeah, so it'll just be Tuesday. Yeah, you know what? You could. Oh yeah, no, this is the first time I've done this. I was gonna say, you look back to last semester. This is a new practice exam. But I did do a different practice exam. You want to look back to YouTube old semesters? It's a different practice exam though. Changed it this time. Yeah. So. No, I mean yes, it's the same, but it's not the exact problems at all. It's the same type. Like I do one of these, and so I do. Yeah, they're one of each type. Oh. Mr. Sky, gotcha. Thank you.
I think there's no practice exams you did, like over the weekend or something.
No, just this one. Well, I'll give it to you tomorrow. Yeah. Yeah, I'll bring it tomorrow.
And then, is this going to be harder?
No, it'll be a bunch of homework questions.
Oh, okay. So
But
it's not going to be, but it is like, it's not crazy except for,
It's just like that. Like it'll be all homework problems. Yeah. And then you'll see it tomorrow. You'll see exactly. You'll be able to take a week down the weekend. You'll be able to see exactly what it's like. Yeah.
So my pool is weird. I don't know what's going on.
And point 1, I think it's because go into your window. I think your something's maybe it's that. Yeah, that delta x. Just make that 1.
the window area. 'Cause I
Try
couldn't
graphing again now.
know how did you get mine?
What's your Y? Now hit table.
Oh yeah.
But you got still graph.
Okay.
Second.
So
There.
I said it to like, oh, check the table.
That is funny.
The table.
X is 0.1 again. Did it do that again?
You do second two.
No.
And then when we look at the
What's your
table, we
function?
look
So
at the X,
324x minus, what was it?
72x squared plus 4x to the thing.
Yeah, that looks good. And what's your window? Oh, you went to 94.
I don't know.
Yeah, I just went 0 to 9
this step.
and 0 to 500. Let's try that. So there's the graph. Let's see what the table says.
Justine was not.
That's weird, huh? Let me see what mine says, because I'm set the same now.
No, no.
Yeah, weird. Isn't that weird? Yeah, mine's 1. Why is your X 0.1? I wonder.
You didn't finish?
Oh, it did the delta X thing again.
Maybe change it to 1 again.
Yeah. And let me graph. Oh, what did it do?
It's resetting it over.
It is. You know what I can do? I can just reset the whole calculator to factory level. Did you have anything saved on it? You want
I
to
have no clue. This is my girlfriend's calculator.
Oh, so maybe I better not do that.
Yeah.
If she has something saved that she
Yeah.
likes, yeah. It's in some weird mode. I'm not sure exactly what mode it's in. Oh, it did that again. Look,
Yeah, I don't know.
it's in some zoom mode or
Maybe it
something.
could come in early tomorrow and have that worked out.
If
Like
well,
some-
you could ask her if you
Yeah.
could reset it. All it's going to do. The only problem is if she had any programs. Like I bet she doesn't have any programs. Where's program? There's a program button somewhere. I can't remember. In the memory. Anyway, the way you would do it, so you check with her, say, hey, do you have any programs saved on there you want to keep? She probably will say no. You just hit second memory, like I just did. Come in here, go down here and go to reset. Hit enter. It says, do you really want to set it? And you, I'll stop right there. But you'd say yes, yes, and it'll reset it all, and it'll be back to factory. Ways.
Thank you.
Yeah.
I'll email you for that.
Pero si le salió bien derecho.